Hello, everybody. This is Stacy Kruzik from Zebra Developers, and I'm just going to go ahead and start the podcast now, or start the webinar now. A couple of house rules. If you have any questions at the end of this webinar, please type your questions into the box and we'll go ahead and address those. A couple of housekeeping items today. Just wanted to let you all know that if you have not already joined our developer community, please feel free to do so at developer.zebra.com. You'll find information about our webinars, podcasts, blogs, and technical information all on that community, which is free to join. We'd love to have you on there. Next, I wanted to talk a little bit about our upcoming app forum. Every other year, we introduce our Zebra app forum, and we're going to be doing that again in 2019. It's specifically geared towards developers and our tech leaders. We're gearing up for that to kick off in our EMEA or Europe location, Warsaw, Poland, June 4th through the 6th of next year. China and Australia are pegged for August. And then we're also firm for the Americas in Las Vegas again, September 30th through October 2nd. And you'll have to join our community and watch for upcoming information on that. And we'd love to have you join us at our app forum. And with that, today I'm going to introduce Darren Campbell. He's our subject matter expert for today, and we'll be talking about securing your devices. Darren, you're on.
Okay, thank you, Stacey. Can everyone hear me okay? Or wait, I'm just asking you, Stacey. I think, can you hear me okay?
We can hear you just fine.
Okay, brilliant. Okay, thank you. So I'm going to be talking today about securing your Zebra device. And the reason we chose this topic, or I proposed this topic, is because there's an awful lot of verbiage of presentations already out there on why Android is secure and the inherent securities of Android and consumer Android, and Google have their security review that they release every year. There's an awful lot written about that, but what there's a lot less on is what we here at Zebra are doing to make your Zebra Android devices even more secure, so security plus plus, if you will. So we've got a number of features, and I'm going to be going through each of these features and demoing them. I've got a few videos set up, so hopefully it gives you an idea of what security features are available that you could add to your applications. Now, these are exposed through what we call our MX layer, our mobility extensions layer, which means they're accessible to administrators as they're staging the devices. So typically, whoever's locking down the device would be an administrator, and they're securing it. They're creating a whitelist of applications that can run. They're detecting, or they're setting up threat detection beforehand. But you can access any of these features through our developer APIs. And because this is a DevTalk, I thought I would go ahead and just talk about this from a developer point of view. But just all of this, bear in mind, can be accessed as an administrator. You see, we've got a few things here on the agenda: Threat Manager, Encrypt Manager, Access Manager, and then some of the other security techniques that I'll be going over. All of the code that I'll be presenting today is available in GitHub, and the links are at the back of the deck. So if you go on to our developer portal and you click on EMDK for Android or EMDK for Xamarin, those are our two native developer kits for Android, and you click on profiles, then you'll see all of this large swathe of managers, or CSPs as we call them, that you can access and interact with. And they're kind of into groups, and the security group is down at the bottom right hand corner there, and those are the managers that we'll be talking about in this presentation. So you are able to access them from both Xamarin and Android. I normally do these presentations and I have all of my code in Java, but that gets a little bit samey, so I decided to create today's presentation in Xamarin to just switch things up a little bit. So like I say, the code is available in C# in that case. So just to go into a little bit more of detail of what these threat managers do. So Threat Manager enables you to detect that your device has been potentially compromised, rooted. You can detect that on startup, or periodically scan for that that condition. Encrypt Manager enables you to encrypt internal or external storage, and it supports file system encryption as well as full encryption. We'll go into more detail on these. Access Manager set up a whitelist of applications that can run and other lockdown capabilities. And then the other managers here enable, disable the camera, add certificates to the device. We have some specific access to the device admin APIs. Yes, not every device admin API is exposed, but some of them enable, disable SD card and enable or disable access to ADB. So talking about Threat Manager, first of all then, what does Threat Manager do? So the idea behind Threat Manager is it will detect a threat, and a threat can be defined as an application has been removed from the device. So the documentation will talk about the EMM or MDM client having been removed, or it could be any application as it's implemented. Maybe the device is being managed by Microsoft ActiveSync. There's an external threat been detected. This is triggered by the MDM or the EMM. The device has been rooted, like I mentioned earlier, and it can check for that both on boot of the device and as part of a periodic scan. So just to emphasize, this is over and above the existing features and security capabilities of the Android operating system itself. So when any of those threats are detected, a countermeasure can be performed. So some of the countermeasures are on the right-hand side there. It can lock the device, perform a factory reset, format the SD card, all the stuff that you might want to do to protect your data should your device become compromised. So let's see this in action. So we're going to be pretending, so to speak, that the EMM client has been removed by some nefarious means. Now, I don't have access, or it's probably a little bit too complicated to try and set up a SOTI system or MDM of your choice. So I've just written a small application which will be pretending is the EMM. And as a countermeasure, we're going to lock the device so that if anyone's stolen this device and they're trying to do something with it, they won't know the PIN or the password. So they're locked out of what they're able to do. So most of these videos have a similar look and feel, so hopefully this is coming across well on the web screen. So on the right hand side here is a TC51 running Android Nougat, which is the latest build at the time of the recording. And on the left hand side here, I'm showing my whole screen so you can see what I'm doing over ADB as well. So I'm just demonstrating this application here, which we will be taking as the EMM client, whereas it's actually only substituting for the EMM client. So first thing we need to do in order to ensure we can lock the device is to specify a PIN, and I'm going to choose a highly secure secret PIN, so make sure I remember that. And then going back to the application which I have written, if I just pause here, just talk about this briefly. This is the application available from GitHub, written in Xamarin. You could have written it in Java, but I did it in Xamarin. And this is just there's a number of these profiles defined, and you define these with the plugin to Visual Studio. Details in the documentation, and once you've defined the profile, for example, this particular profile will contain if EMM client is removed, then lock the device, or some XML representation of that. Then once that profile is activated, it's in effect. So it will be monitoring for the removal of the test package. So the profile has been applied, and now we will simulate someone being nefarious and uninstalling our client test stub here. So I'm just going to pretend I've done that through ADB, and you'll see the screen goes black. Obviously, this is a remote desktop a remote view on the device, so you didn't see what actually happened on the device was the screen went blank because it had been locked. So probably not too interesting to see, but hopefully that gives a sense of what the threat manager can do. Having removed an application, it could perform some countermeasure. So obviously that's not too exciting. A countermeasure, you can imagine any number of ways that a nefarious evildoer could bypass that particular countermeasure. So let's do something a little bit more interesting. So the same threat, again, it's the easiest threat for me to simulate, to be honest with you. So the new countermeasure is we're going to send a custom threat message. We would be, so this, what actually happens here is an intent is sent to a, well, it has an action, and you can send it to a specific application, and then that application can handle the threat as it chooses to do so. So it might lock the device, it might wipe the device. You have the full range of the MX toolkit available to you in your application to lock down the device however you choose. Maybe you choose to encrypt the device or whatever else. The imagination is the order of the day there. But what would that look like? So the application that will receive the threat message. Oh, sorry, I've gone. It's all gone wrong. It's all gone wrong. Okay, we can get this back. We can recover. So the application which will be receiving the threat message is written in Java. All it's doing is displaying a random number on the screen and showing an alert message, but here you would do like device encryption or something else to as a countermeasure to your EMM client being removed. So that's the application. The application is running on the device. This is in the onCreate method, so I think the intent must be getting sent via start activity. That's not configurable, so you just have to make sure you're listening for the intent in the right place. So here I'm setting the profile which will send it's called an unsolicited alert, but it will send that intent when the threat condition occurs. So here I am in my receiver, and I will trigger the condition of the threat. So uninstall the client stub and keep an eye on that right-hand side of the screen. You see I get the toast message and I get the unsolicited alert with the random number. So that shows a little bit more complicated way of handling a threat. So that's the threat manager. Moving on to the Encrypt Manager. The Encrypt Manager supports full encryption for SD cards and internal storage. It's been around since, I'll probably jump around in the slide a little bit. It's been around since JellyBean. So think back, what was available in Android under JellyBean? There wasn't a lot of encryption going on. You know, maybe it was an option. I think they introduced it in Lollipop as an option, maybe, or KitKat for full device encryption. We're now living in a world of the internal storage on Marshmallow devices is encrypted by default, and external storage doesn't have to be encrypted, but there is this notion of adoptable storage on Marshmallow that you can like adopt your SD cards and they will be encrypted as part of that. So the key here is this Encrypt Manager has been around for a while. If you want a common technique to encrypt internal or external storage, then the Encrypt Manager is a good choice for you. If you are just interested in encrypting external storage in a way that's easy to stage, I mean, obviously you have to put the SD card into the device, so that obviously doesn't scale too well if you've got hundreds of devices, but once the device is in there, just being able to initiate encryption through Stage Now or through an application may well be a very useful and helpful thing for you to be able to do. So I just want to make sure everyone is on the same page with regard to adoptable storage, because encryption is obviously a huge topic, and there's lots of different techniques for encryption and ways that people might go about doing this. So adoptable storage on a Marshmallow device was introduced, so now we can have an SD card which is considered by Android as part of internal storage. Now I'm emphasizing this because the Encrypt Manager and adoptable storage, you don't have both of them at the same time. You either have one or the other. And I'll just show this video to make sure that everyone's on the same page with what adoptable storage means. It's just very short. This is the process one goes through to adopt an SD card. So you get this notification, set up your new SD card. I'm going to say use as internal storage. And when I do that, it requires a format of the SD card, and it will afterwards be encrypted, and it will actually appear to Android as internal storage. I'm not too familiar with the details, but you know, that's pretty much the high level of how it works. So we're not using adoptable storage here, we're using Encrypt Manager. The SD card is a separate external card which we can remove from the device, but we want to make sure that anyone taking that card and stealing it maybe is not able to access the data. So let's look at how we would use Encrypt Manager to make sure that that data can't be removed from the SD card. So the first thing we do, and this isn't part of the demo, but you need an encryption key. So I generated mine with OpenSSL on my Windows machine. It gives me a key, and I need to add that key to my profile. And then once I have my key, I'm able to encrypt the SD card, the external storage card. The card is then wiped, can be subsequently read on the device, but not off the device. So let's just go through this demonstration. So I have a test file. The test file is at the moment on my machine. So I'm just going to push that to the SD card on the device, which in this particular device, obviously your device may vary depending on the build of Android, etc., is SD card 1. Now that the file is on the device, I'm able to go to storage, SD card 1, test file.txt, just to show, yep, the file is indeed there. So at this point, the SD card is not encrypted. I just shoved it in the back of the device. Everyone was happy, and so the first thing we do is install the key. This is the key that I generated offline. The key is part of the profile, and I can then encrypt the SD card. You see it flashing up here just to show that it's being accessed. Profile has been applied successfully, which means that the data on the card is now encrypted. So in terms of applications on the device or the user just viewing this through file browser, first thing you notice is all the data's gone. Why is it gone? Well, it's not hiding under SD card 2. That's because the SD card was wiped as part of the encryption process. This needs to be done. So we'll copy the test file back over just so we've got some content on the card, test file.txt, the file is there. We're able to pull the file from the card because the device has knowledge of the installed key, the encryption key, sorry. And so I'm just showing here that I was able to successfully copy the file off. And then what am I doing now? I am going to restart. No, I'm going to take the SD card out. Sorry, I just referred to my notes here. Take the SD card out. I just want to show that that card was successfully encrypted. They're going to be any second now inserting the card into my Windows machine. This is running Windows 10. I apologize, it's a little bit small here. You probably can't see it, but it's installed itself here as drive F. I've got quite a few drives, obviously. This is the machine I use for work every day. And here we are. So drive F, it's saying, I don't understand this card. Do you want me to format it? What do you want to do? So the reason for that is because the card itself is encrypted and my desktop doesn't have the key to decrypt the data. So you might think my test file was lost, but no, all is not lost. I can add the SD card back into the device just like you would expect. I think I probably missed out a bit of time in the video there, and you could, or you should be able to now see that the file is again on the device. So I can pull the device, I'll pull the file again, just rename it to file 2, and here we go. The file still contains this is a test file, test text that we had previously. Okay, so that was the Encrypt Manager, sort of the basic functionality of Encrypt Manager, just encrypting an SD card. Could have done that on internal storage, but it's a Marshmallow device, so it wasn't really necessary. It comes encrypted out of the box. So let's
Darren, we have a question from the audience on this specific topic. Do you want to stop now?
Is it a long question or?
No, I'm hoping you can answer it fairly quickly.
Oh, yeah, sure. Go ahead, Robin.
I have somebody who is asking on this particular topic, is it possible, for example, to store a 5 GB file onto the SD card if it's encrypted?
I don't know why it wouldn't be, as long as the SD card was large enough and the file table, whatever the file system, sorry, of the SD card was able to manage 5 GB files. I don't know why that would be an issue, but I can get back to the person that asked the question if it is an issue.
Right, sounds good. Thank you.
Okay. Thank you. Okay, moving on. So let's combine the two. Are we combining the two? I think we are. So we're going to revoke. Oh no, we're not going to combine the two until the next demo. Sorry about that. See, the question threw me, but we're here. So we will we'll install the key as before. Encrypt the SD card, again, files can be written or read, and then by revoking the encryption key, we'll just demonstrate that the contents of the card can no longer be read because that key is no longer present on the device. It does require a device reboot, but we'll come to that as the demo proceeds. So again, into the test application, it's a different profile this time. Now it's the revoke. Well, I need to install the key again, just to make sure that that's installed. That's a separate step. And then I'm going to just show that I think this is all very similar to the last demo. So I'm going to skip ahead to 55 seconds, I think it says in my notes, and then we'll see the key being revoked. Okay, so everything's the same as before. The card is encrypted, but now we've revoked the key. So the device no longer has knowledge of the encryption key that was used to encrypt the SD card. So until the device is rebooted, it's just how it's implemented. We're still able to see the text file on the device. So now we reboot, and after a reboot, the expectation would be the SD card would no longer be active, no longer be accessible. Just like I was able to access I was unable to access the encrypted SD card on my Windows machine, I should no longer be able to access it on my device. So already it started to say corrupt SD card, so we know something's wrong. We go into storage, we don't even see SD card 1, it's not even a selectable option. So how do we get out of this scenario? We go back into the Encrypt Manager, we install the key, preempting what's being shown in the demo. Just ignore that error. That was because I tried to use the MX service too quickly after the device had started. So I've come back a couple of seconds later, and then I click install key again. Sorry, I should have cut that bit out of the demo. The profile's now applied, so we should be able to access the SD card. We can't yet because we haven't restarted the device. So let's just do that very quickly. I think I would have cut some of this out. So hopefully it's you're not watching this in real time. But the expectation would be that after the key is reinstalled, because it was the same encryption key used to encrypt the card in the first place, the card would now be accessible. And so we can very quickly show that under storage, SD card 1, test file.txt is our handy test file.txt. Okay, brilliant. So now let's put the two together. So we've got the threat manager and the encrypt manager. So we're going to detect a threat, and after that threat has been detected, we're going to revoke the encryption key, because in this scenario we know there's been some kind of threat, and so we don't want any of the data that's on the card being viewed, because someone's got the physical device, even though the card is encrypted, they could still see that data. So by removing the encryption key and rebooting the device, we make it so nothing. There's no way for our evildoer to view the contents of our SD card. So back to the trusty TC51 again, and the file browser application, just to show that there is some contents on this SD card. I believe at this point it would have been encrypted for the purposes of this demonstration. So now in the threat manager, back to this first screen again, I'm going to revoke encryption keys when when the threat is detected, which means the EMM client had been removed. So let's just remove that test application, just like I did in some of those first demos much earlier on. And then the device locks because we're executing our countermeasures, and then we just need to make sure that the device gets rebooted. You might do this from another application because remember previously you could send a message to another application, so maybe that other app is the one that's rebooting the device. But I'm just going to skip ahead to 1 minute and 50 I've got in my notes here, which is after the device itself has been rebooted. So I was going to try 1:45. So the device has come back now from a reboot. The expectation is that we're not able to view any of the data. See, it already says corrupted now. I probably don't need to go to the extent of opening up the file system to show that the data is no longer on the device. Someone, if they had stolen this device or if they had rooted the device and removed our EMM, they no longer have access to the encrypted data. Okay, so that is Threat Manager and Encryption Manager. I'm going to talk about Access Manager, which is the final like big security manager before we move on to some of the smaller functionality. So Access Manager allows you to specify a whitelist or of user applications. So we're not talking about system applications for the Access Manager. We're just talking about user apps or line of business apps, or not system apps. And it controls whether or not applications on that whitelist can perform privileged functions. So remember I mentioned earlier on about rebooting the device from an application. You can do that using MX, but you might want to prevent applications from using those privileged functions. And you can do that by not whitelisting that app to use MX. So there's essentially like two whitelists. There's a whitelist of whether the application is available, and there's a whitelist of whether the application can perform privileged functions through our MX layer on Zebra devices. So our packages can be removed or added to the whitelist. So effectively, it's a blacklist as well. It took me a little while to get my head around. So if you're struggling with it, that's why I put all of the code for these demos up on GitHub to just have a look at exactly what I'm doing in the application. And quite interestingly, you can lock down the whitelist with application signatures. And I'll get to that in the demo in a couple of slides time. And you can also control whether or not you're showing the full gamut of settings on the device. So a simple whitelist then. We've got two applications here. We're going to whitelist them. I think we've got a test application that I've written, just a dummy hello world application, and the test application itself. Just be very careful when you're doing any of this kind of whitelist functionality. If you don't whitelist the test app disappears and you end up having to factory reset the device, and it's a big pain in the bum. And I had to do it, excuse my language, I had to do it a couple of times in the process of putting this demo together. So don't make the same mistakes I did. Two applications whitelisted. Here is an application called Bubble Blast, which was really fun. This is back in the days when applications weren't trying to get you to buy things every couple of turns. Obviously, you're not here to watch me pay Bubble Blast. This isn't Twitch, but I'm just showing you there is an application on the device, a user application that we would not want our enterprise users to be playing. So now I have executed the whitelist, and you can see that the Bubble Blast has disappeared. I still have access to the security manager. Let me just pause there. I still have access to the security manager's test app that I've written here, so I can get myself out of whitelist, and that's one of the whitelisted applications. But also notice here, this is a reduced setting. So with reduced settings, there's more than one way to do this. I've actually written blog posts about all the different ways that you can reduce the settings available to users in the past. But here's one way, and so you're just left with, or your user is left with, the volume, display brightness, and just system information. So I think that's everything in this demo, other than to go back into the application and to disable and show that when the whitelist is disabled, then I'm pretty sure we will see Bubble Blast make a reappearance. Here it is. So Bubble Blast is now available because there is no whitelist in effect. You do need to specify settings to be full settings as a separate step, but I didn't do that in this demo. So that's the simple scenario. Then I talked about application signatures before. So imagine a scenario, if you will, where we have like that whitelist was just dependent on packages. So I had whitelisted my test application, which was called something like com.darrencampbell.security managers. Now, although there are there's other ways in Android to stop someone from replacing my app with another application which has the same package name, it is possible to circumvent them, especially on a rooted device. So if somehow, again, our evildoer is able to install an application with the same package name as something on the whitelist, typically that evil application, that harmful application, I'll stop using such emotive words there, would be able to perform actions that we did not want it to be able to perform because it has the same package name, so it's on the whitelist, it's displayed, no problem. That's why there's this feature called signature, or you can apply a signature to the whitelist in MX. So the signature, I was quite confused when I read the documentation for this, so I want to make this clear what this is, what this signature is. So when I read signature, I thought, okay, I need to create a hash, like get an MD5 hash or something of my APK file before I install it on the device, and that's the hash that I'm going to be providing to this API. No, that's not the case at all. And then I thought maybe, if you use like a cloud API from Google and you have to determine like the SHA-1 signing key that you gave for that app, I thought maybe it's the signing key I need to provide. So then I wanted to do all of this without asking anyone. And then I tried that, and no, that didn't work either. What you actually need to do, and I'll work with the docs team to get this made clearer in the documentation, is to provide the signature as defined at develop that link there. It's a signature class. It is a quote opaque immutable representation of a signing certificate associated with an application package. Now, as far as I'm aware, you're only able to obtain these at runtime, and I've got code on the following slides showing how to do that. But in this demo, I'm going to show that I've got the same application. I'm going to use my EMM client stub again. And there's obviously a debug variant and a release variant when you create an application. So what I've done, they've got the same package name, obviously. I've got the debug variant is whitelisted, but and the signature of the debug variant is whitelisted, but the signature of the release variant is not. So I'm just going to show how the signatures and whitelists can be used to make sure that I'm only able to display to my users a application which I can be sure is the application that I want to show. So I'm back, trusty old TC51 again. I'm going to install the debug version of, I'm going to install the release version, it looks like. Okay, I've installed the release version. I might have said that slightly around the wrong way, but the demo will be the truth of all. So this is my security manager's test app. I'm just enumerating a couple of applications and determining the signature which I need to provide for these two applications I'm going to whitelist. So the first one is the test app, the test app itself. Remember I said before, make sure you whitelist your test app. And then remember I said I had trouble defining these whitelists. Well, this was an instance where I had to factory reset my device a couple of times. So just, again, don't make the same mistakes as me. These signatures can be quite long. That's the kind of length of a signature that you're looking for. And then this will be the signature of the release version of the EMM client stub. I'm just going to concatenate those together and put a comma between them. And then I need to provide those in the definition for the profile, which I will then execute, and that profile contains the definition of the whitelist. So just to show it end to end almost, under EMDK, it's called the signed whitelist profile. I apologize if this is small, there's no way to make this larger, but this doesn't last very long. So I'm just going to copy and paste into these two fields. These are the whitelisted application package signatures for both the apps themselves, and I've also given them the ability to execute XML because my test app needs it. So now I will execute that code. I need to obviously be running the updated version, this version of the test app I've just modified because I just edited the profiles there, so I need to make sure I've got the latest version. And then under the access managers, what am I doing? Okay, I do apologize. Come back to the security managers. I think I'm just showing that everything was still installed there. So back to access manager, and then if I execute that signed whitelist profile, everything disappears. So I can't pay Bubble Blast anymore, much to my chagrin. And everything slowly disappears, and now all that's left is the EMM client stub, and if I can, and the test application. So that's good. That's what we would expect. We would expect those two applications to still be visible. We haven't really shown anything different from the last demonstration. Here's the release version of the EMM client stub. But remember, let's get rid of this notification. Remember that the package signature that I use was associated with the release version of EMM client stub. So now we'll uninstall EMM client stub just to make sure that it's gone. There, go away, never see you again. And now we install the debug variant, which of course will have a different package signature. Let's wait for that to install. So the expectation here is when we execute that signed whitelist, the expectation is for us to not see the EMM client stuff. So there it is. I'm clicking on it just to show that it is present on the device. It installed successfully. There's good old Bubble Blast, but we're too busy to play that. We have to execute our signed whitelist, and now we go back and we'll see that EMM client stub disappears because it did not have the same signature. So that's what we expected to see. We don't get any message. There's not even in Logcat. There's not a, hey, you tried to whitelist this app, but the signature didn't match. So I had a bit of a frustrating time. It was trial and error, and that's why, hopefully, by me talking about this, some people on this call and listening to this video won't make the same errors as I did. But like I say, I will make sure the documentation is updated. It should be easier to use. So that's package signatures, a very powerful feature. So how do you get those signatures? So in Xamarin, the code is as follows. So you're using this signatures, where is it? It's package manager.get package info, and then signatures comes out of this end, and then you can enumerate. I don't know why. It seems to return an array of signatures, but I just take the first one. I'm sure there is a proper reason. And then in Java, the code looks like this. It's the same code, obviously, because Xamarin is just wrapping the Android Java APIs, but this is how you do it in Java. So that is Access Manager. So I've covered Threat Manager, Encrypt Manager, Access Manager, and now we have a collection of much smaller security, like point functionality that you might want to do. The first one, I'll just start the video off and then talk at the same time. First one's the Camera Manager. So this is quite basic functionality. Being able to disable the camera is exposed through most EMMs, through pretty much all device owners. And you see at the moment here, I can't connect to the camera because I've disabled it. So it's actually disabling it at a very low API level. So any app that has like an inbuilt camera view or the camera itself is not able to use the camera. Or so an advantage of our Zebra devices, you can still scan barcodes. On a consumer device with a disabled camera, you wouldn't be able to scan barcodes. But having re-enabled the camera, you can see my desktop and very brief view of my desk there. So that's the Camera Manager. Certificate Manager enables you to install custom certificates. So we lump it under security, but it's not. It's a way to enable you to work in your secure environment, whereas the other features we've discussed have been more about locking down your device or preventing the user from doing things. Installing a certificate, a certificate that you've signed yourself, and have the device trust that signed certificate, is a way to enable your device to work within your organization. So I've previously created a ca.crt file, a cert file, and that's also available in GitHub. But first of all, in the video here, I'm just showing that there are no trusted user credentials installed on the device. So what we'll be doing in this application is installing such a CRT file, a certificate. You don't define the contents of the certificate in the profile, you just define its location on disk. So here the certificate is going to be searched for in internal storage, storage SD card 0 ca.crt. So having copied the certificate to the device, I can then execute the profile, which will install the certificate. And as long as the certificate is well formed, obviously, you define these certificates using OpenSSL on the desktop. When I go back into trusted credentials, user, you see I have a certificate which I've created myself, and I've plastered it with my name all over so that I know it was one that I created. So what I could then do is it's very powerful. The use case I'm most familiar with, to be honest, is I can then have a web server and I can sign that server myself. So the pages being served by my web server from my URL can be served over HTTPS. And because I have signed the connection, my device trusts that connection, I get the little green tick when I browse those pages on my web server, and that is then a trusted connection between the device and my server. Otherwise, the alternative is to purchase a secure certificate for, there's a very expensive, obviously, through a third party. I don't need to do that if I'm running within the four walls. I just want to make sure that my internal connections are all secure with self-signed certificates. So there you go. That's installing a certificate with the certificate manager. SD card manager does what it says on the tin. Well, I suppose a little bit of explanation wouldn't go amiss here. So this enables us to enable or disable use of the external storage card. So maybe like one of the countermeasures from earlier on. I encrypted the SD card, but I might have also wanted to prevent the SD card being read on the device at all. So at the moment, I can read the SD card, but when I disable the SD card with this test application, immediately you saw the little SD card icon disappear. Go back to file browser, and then under storage, SD card 1, not there. It was previously, but now it has gone. It's no longer readable on the device. I also couldn't read it via ADB either if I tried to. If I re-enable the SD card, it's still there. It hasn't wiped it or anything. It's just hidden's probably the wrong word, but I'm no longer able to access it on the device. Sorry, went too far there. Only a couple left, a couple of managers. So device admin, we expose some of the capabilities of device admin, the API, what you see under developer options. This particular one is the ability to disable unknown sources. Is this, yeah. So this is the ability to sideload an APK onto the device and have that APK be installed. So now I've disabled unknown sources, and just notice that all this is doing is modifying that option in the developer options there. So it's a way for you to programmatically just set that config option. It doesn't prevent the user turning it back on. So make sure you do something else. Maybe use Access Manager to enforce restricted settings so that your user is not able to go into the developer options and turn it back on themselves. Final video, and thanks for everyone who's stayed for the duration of these. USB Manager is the ability to enable or disable the ability of the device to communicate via ADB. Yet another one, make sure you have a way to turn it back on after you turn it off. So here we are, we have one device visible on the machine. If I disable ADB, it's gone. Because the device has had ADB disabled, and then when I re-enable it, then I don't know if Visor's going to come back and the device is now visible. But like I say, make sure you don't implement disable before you implement enable. Otherwise, again, it's probably going to be a factory reset at that point, and that would be a little bit trickier to do because you wouldn't have AD. I don't know if it affects Fastboot actually. Now I come to think of it, that's a question for another day. Does USB Manager affect Fastboot? I suspect it does, but I'll leave that as an exercise for the listeners. Okay, so all the resources shown in this presentation are under GitHub. The link is here. So this is the page. If I zoom in here, there's the stub application, there's the security manager's Xamarin application, there's the application that received that unsolicited alert, right back at the beginning of the presentation. There's the CA cert file, and well, you can probably make your own test file, but there's also the test file.txt. I think I just uploaded everything that was in my folder as I was developing. Videos are available on YouTube, but probably best to just watch this presentation for context. And with that, I will go to questions. We've got about a quarter of an hour left of the webinar. I will just say, to emphasize what Stacey said at the start of the call, developer.zebra.com, our developer portal. Please visit there if you have additional questions after the presentation. You can sign up for our newsletter, join our ISV program, and I will hand it over to Stacey or Robin if you have anything more to say on this slide, please, or if there's any questions, then let's take those now, please.
Thanks, Darren, so much for giving us this really good overview and some details on how to actually do this stuff. We did have a couple of questions, especially on the encryption manager. The original question around the 5 GB file, they wanted to clarify that would it be possible to store a single 5 GB file, say as an MP type of file, on the SD card if it's encrypted?
Yeah, I don't know why it wouldn't be, as long as the file system is able to handle files of that size. There's no reason why it shouldn't be, unless I'm missing something, in which case we can get some more details.
Okay, sounds good. Yeah, we have the person's name, so we can always follow up.
Sure.
The other question I have, or I've got another question here. Can the key be shared across many different devices? As in, an SD card could be removed, read on a PC, and then inserted into a different TC51. That's the key.
I haven't tried it. I don't know why it wouldn't work. I don't know if maybe there's some logic at the lower level, which is hashing it against some unique device identifier. So that's another one that I could get an answer offline for. It's an interesting question. I hadn't considered it. I don't actually have a way of testing because I've only got a single device here, I'm afraid. But yeah, sorry, I can't provide a concrete answer for that. But the answer is I think so. I think it would work.
All right, if they responded that they'll give it a try. Outside of this wonderful presentation that you're giving, what are some of the more, what are some of the documentation sources that could be provided to customers or other partners to help people understand that using MX and using these things can make the Android devices as secure as iOS? Do we have any other references? Where would you recommend they go for those references?
We don't have any specific references, like with regard to is Android plus MX as secure as iOS. I mean, what you're more likely to find if you look around online, you'll find documentation from Google. I think very recently in their most recent security report, they compared themselves to iOS. So the comparison there was an Android device running the latest operating system, which is a GMS device, compared against iOS, how many flaws, how many potential attacks were there against that product. Now, obviously, if you're thinking about Zebra devices, they're not, today they're not running Oreo yet, so it's not a fair comparison with regards to that, but then we have the MX on top of that. So we don't have anything specific regarding iOS, but I think if this question came from internally and we were thinking about talking about this with a customer, then you would probably lead off with just Android in general compared to iOS and the security around that, because there's more external papers available on that. I don't have any links specifically, but like I say, have a look at the recent security report from Google as a good starting point.
Thanks. I don't see any more questions come in. Are there any more questions out there? Please type them in the questions box on there. Okay, we've got one more. Can MX be licensed to other devices? Not sure if that means other non-Zebra devices or.
Yeah, so non-Zebra devices, no. MX is only available on Zebra devices, just like our SDKs are only available on Zebra devices as well, because the functionality is all part of the same intellectual property, which is stored on the devices. So it's important to understand the versions of MX. So as you update your device, so it might be a lifeguard update, or it might be a full operating system update, or it might even be a jump in Android version from Marshmallow to Nougat or Nougat to Oreo. You will be receiving more updated versions of MX, and you have to make sure that the capabilities of MX that you're targeting are appropriate for the version of MX which is running on your device. But yeah, I think the question was probably more about, can you run MX on non-Zebra devices, and the answer there was no.
Okay. Okay, not sure if this is a question. Sorry.
Mine's raised.
I think they're just pointing out that the configuration manager approach that we have used and applied was recently shared at the Android Enterprise Forum, so I think it's more a shout out.
Okay, so yeah, when we're talking about managed, that's probably a key point that I didn't mention actually. So yeah, the managed configurations can be used on, that's the coming form for managed and unmanaged devices, and so also all of this functionality I've been discussing here is available on managed and unmanaged devices. And I think the MX versions go back to KitKat or JellyBean in some instances. So you would have been able to use this on all of our existing devices which we have out there today, pretty much.
Sounds good. Thanks, Darren.
Okay, so are we
unmuted?
Is that the last question then? Are we done for questions?
Yeah, it looks like we're done with questions, Darren. So just a couple of notes for everybody. We'll have this slide deck and also a video on our YouTube playlist. We'll post that in the dev portal. So again, it's beneficial to join. And with that, I think we're done. And thank you, Darren, for an excellent presentation today. Thank you all for joining us.
For listening. Yeah.
Have a great day, everybody.